Welcome to Fun Facts Daily, your source for just the good stuff. Monday through Friday, we're bringing fun facts and news you can use, all carefully curated to uplift and inform. So give yourself a break, relax, and learn something awesome in just a few minutes every day. Hi everyone, I'm Kyle Wood, and today we're going to be learning all about vacuums. But before we get into the facts, let's warm up our brains with a little challenge to see if you can tell fact from fiction. Consider this. Before the automotive age, it seems like everything relied on horses and other animals to do hard labor, whether it was for travel or plowing a field. But would you believe the earliest vacuum cleaners were actually horse-powered machines that sat outside your house? Imagine a giant horse-drawn carriage pulling up to the curb just to suck the dust out of your rugs through a long hose. What do you think? Is this an actual fact or too good to be true? We'll find out at the end of the episode. Now for your word of the day. Our word for today is barometric. That's B-A-R-O-M-E-T-R-I-C. Barometric is an adjective relating to or indicated by a barometer, which is an instrument used to measure atmospheric pressure. In the context of vacuums, understanding pressure is key because a vacuum cleaner doesn't actually suck in the way we think. It creates a low pressure area inside the machine. Because nature generally loves things to be balanced, the high pressure air from the room rushes into that low pressure space, carrying the dirt and debris along with it. The word barometric combines two Greek words, baros meaning weight and metron meaning measure. So it literally translates to weight measure, which is exactly what scientists like Evangelista Torricini were doing when they first realized that air actually has weight and exerts pressure on us. When you use your vacuum today, you're essentially using a tool that manipulates barometric principles to keep your floors clean. Time for your daily high five, our top 5 fun facts about vacuums. Number 1. The precursors to the modern vacuum didn't actually suck up dirt. They tried to blow it away instead. Early inventors in the mid-19th century struggled with the concept of creating a seal to pull air in, so they built machines that used bellows to blow powerful gusts of air. These carpet sweepers would essentially blast the dust off a rug and into the air or a nearby box, which often just made the rest of the room even messier than before. It took several decades of trial and error before engineers realized that pulling air into a filter was a much more efficient way to actually remove the grime. This blowing method was popularized by inventors like Daniel Hess, who patented a carpet sweeper in 1860 that used a complex system of bellows and water to catch the dust. While it was a step up from a simple broom, it was incredibly difficult to operate and required a lot of physical strength. In 1901, a British engineer named Hubert Cecil Booth observed a demonstration of a machine that used compressed air to aggressively blow dust out of train cars, but he noticed the dust simply billowed up and settled right back down onto the seats. He argued that suction would be a far more effective method for permanent removal. To prove his point, he laid his personal handkerchief over the plush fabric of a restaurant chair, placed his mouth tightly against it, and inhaled as hard as he could. He coughed and almost choked from the massive amount of dust he sucked into his mouth, but when he flipped the handkerchief over, the underside was completely black with dirt. This kind of gross but highly successful experiment proved his theory and eventually led to the invention of the Puffing Billy, the first vacuum that changed the way we clean forever. Number 2. The first portable electric vacuum cleaner was invented by a department store janitor using a tin soap box, a fan, and his wife's pillowcase. In 1907, James Murray Spangler was working as a janitor in an Ohio department store when he realized the rotary sweeper he used exacerbated his asthma. Desperate for a dust-free solution, he tinkered with a few common household items to build a much safer and better cleaning tool. He attached a small electric fan motor to a tin soap box mounted on a broom handle and then repurposed one of his wife's pillowcases. Spangler's makeshift contraption successfully used the suction to pull dirt away from his face and securely trap it inside the fabric bag. He quickly realized the commercial potential for this brilliant invention and patented the electric suction sweeper in 1908. Although he had a brilliant patent, Spangler lacked the manufacturing capital needed to produce his new sweepers on a large commercial scale. He gave one of his early models to his cousin, Susan Hoover, who used it in her home and enthusiastically praised it to her husband, William Henry Hoover. W. H. Hoover, a successful leather goods manufacturer facing a decline in the harness business, saw an incredible opportunity in the motorized device. He bought Spangler's patent in 1908, kept Spangler on as a partner, and ultimately founded the Electric Suction Sweeper Company. The Hoover name became so synonymous with the device that in many parts of the world, Hoover is actually used as a verb to describe the action of cleaning using a vacuum. Number 3. Your vacuum cleaner doesn't really pull dirt into the machine. The weight of Earth's atmosphere pushes the dirt inside. While we commonly say the vacuum sucks up debris, the suction is not actually an active pulling force from the machine itself. When you turn on your vacuum, an internal motor spins a fan at incredible speeds, often reaching tens of thousands of revolutions per minute. This high-speed fan forces air out of the exhaust port, leaving behind an area of significantly lower air pressure inside the machine's dust canister. Because nature always seeks equilibrium, the surrounding air in your room rushes in through the nozzle to fill that newly created low-pressure void. It's this incredibly fast-moving stream of incoming air that catches the dust particles and carries them up into the hose. This process is entirely reliant on the atmospheric pressure of the Earth, which constantly pushes down on everything around us. Because the pressure inside the vacuum is lower than the outside atmosphere, the heavier, denser atmospheric air pushes its way into the nozzle. This means that a standard vacuum cleaner would be completely useless in outer space where there's no atmospheric pressure to push the air. Although NASA does use vacuums quite a bit, just not in the vacuum of space. And number 4. NASA engineers developed specialized battery-powered vacuums for the Apollo lunar missions to prevent abrasive moon dust from destroying their equipment. When astronauts visited the moon, they encountered a unique problem. Lunar dust is incredibly fine and exceptionally abrasive, similar to crushed glass. Because there's no wind or water on the moon to weather the particles, the dust grains remain jagged and cling tightly via static electricity. During the early Apollo missions, this hazardous dust coated the astronauts' spacesuits and was unfortunately dragged right into the pristine lunar module. Once inside, the particles floated around, irritated the crew's eyes, and threatened to clog sensitive mechanical joints and air filters. In order to combat this, NASA partnered with the Black & Decker Corporation to develop a specialized cordless vacuum tool that could operate safely in space. They created a highly efficient, computer-designed motor that drew minimal power while providing maximum suction, housing it in a durable, compact frame. This not only helped keep the lunar modules free from dangerous abrasive dust, but it also revolutionized consumer products back on Earth. The expensive research and development funded by NASA directly paved the way for the creation of the famous cordless dustbuster in 1979. And here's a little bonus fact for you related to NASA and vacuums. NASA actually has built a massive vacuum chamber to simulate the conditions of outer space. The Space Power Facility in Ohio houses the world's largest vacuum chamber, measuring 100 feet in diameter and 122 feet tall. This massive chamber can pump out nearly all the air inside to create a hard vacuum, mirroring the airless environment of the cosmos. Engineers use this to test everything from Mars landers to rocket fairings to ensure they won't explode or malfunction when they leave Earth's atmosphere. When the chamber is fully evacuated, it holds only about 2 grams of air. That's down from the roughly 30 tons it holds at sea level. This level of suction is so intense that if there were any structural weakness in the chamber walls, the atmospheric pressure from the outside world would crush it like a soda can. So, vacuum technology isn't just about cleaning Cheeto dust off the floor, it's a vital tool for exploring our solar system. And our fifth and final fun fact for today: the fastest robotic vacuum cleaner, at least at the time of this recording, can travel at about 35 miles an hour. Most robotic vacuums are known for their leisurely pace as they slowly and gently bump their way around the living room. But in 2024, an Australian YouTuber named Alistair Laidlaw decided to completely transform this sluggish appliance into a speed demon. He modified an existing robotic vacuum using high-performance electronics, 3D printed materials, and heavy-duty remote control gear to create the Vroomba. To officially earn the Guinness World Record for the fastest robotic vacuum, he had to meet a few criteria. The custom machine still had to look like a standard robot vacuum, use only 2 drive wheels, and it had to maintain functional suction power. During an official test drive, it reached a top speed of about 35 miles an hour, that's 57 kilometers per hour. Now for some news you can use. If you own a traditional upright vacuum cleaner with a rotating brush roll, you probably know the frustration of having hair and string wrapped tightly around the bristles. Over time, this tangled mess gets in the way of the brush's movement, it strains the vacuum's internal motor, and significantly reduces the overall cleaning efficiency. Instead of yanking at the tangled hair with your bare hands or using a big pair of sharp scissors near delicate plastic components, try using a simple sewing seam ripper. A seam ripper is a small, inexpensive crafting tool with a pointed hook and a sharp inner blade designed to slice through tightly sewn threads without damaging the surrounding fabric. You can easily slide the pointed end of the ripper under the tightly wrapped hair on your vacuum's brush roll and pull straight upwards. The hidden inner blade will safely and swiftly slice right through the thickest tangles of hair and carpet fibers in seconds, allowing you to easily pull the debris away in one piece. And now I want to take a minute to just share one, admittedly far less practical trick. As a kid growing up in the 1980s and 90s, I remember seeing tons of ads in the back of magazines like Boy's Life and Popular Science offering plans for a personal hovercraft powered by just a simple vacuum motor. A lot of us dreamed of building one, but we were told it had to be a scam. It turns out you actually can use a standard vacuum motor to power a sort of hovercraft with enough lift to get a full-grown adult off the ground. It's a fascinating application of fluid dynamics and pressure that you can replicate in your own garage with a few basic materials. The secret is the relationship between pressure and surface area. While a vacuum motor or a leaf blower only creates a relatively small amount of pressure, about 2 or 3 pounds per square inch, that force is multiplied across the entire surface area of the craft's base. If you build a circular platform that's 4 feet wide, you have over 1,800 square inches of surface area. Even with a very modest motor, a tiny bit of PSI distributed across such a large area creates a total lifting force of hundreds or even thousands of pounds. This is why a machine designed to suck up dust can easily levitate a 200-pound person a couple of inches off the floor. Now, to build one, you just have to start with a sturdy circular piece of half-inch plywood about 4 feet in diameter. In the center, you cut a hole just large enough to snugly fit the exhaust hose of a canister vacuum or a shop vac. The engine is just the vacuum itself, but instead of using the suction end, you connect the hose of the blower or exhaust port so that you're constantly pumping air down through the hole in the wood. And finally, the most important part is the skirt around the wood. This is usually made from a heavy-duty plastic tarp or vinyl. You wrap the plastic over the edges of the plywood and staple it to the top, leaving it loose enough at the bottom to create a little bag or cushion. Then you're going to want to cut half a dozen holes 1 inch in diameter. You want those evenly spaced in the plastic near the center of the board. When the vacuum's turned on, it will inflate the skirt like a donut, and the air escaping through the small holes creates a thin, high-pressure cushion between the plastic and the floor. On a smooth surface like a gymnasium floor or a flat driveway, the friction almost completely disappears, and you'll find yourself floating on a literal pillow of air. Finally, the moment you've been waiting for. At the beginning of the episode, I asked, is it true that the first vacuum cleaners were actually horse-powered? Well, that's a fact. In 1901, the British engineer Hubert Cecil Booth invented the puffing billy. Because of its size and loud noise, it stayed on a horse-drawn carriage parked on the street. A team of operators in crisp uniforms would park the carriage outside, feeding hoses up to 100 feet long through the windows and doors. The service became a status symbol for the elite, who would actually host vacuum tea parties to watch the impressive machine clean their rugs. Now, I hope you enjoyed learning a bit about vacuums with me today, and be sure to tune in every weekday for even more fun facts. Fun Facts Daily is an Airwave Media podcast. It was written, recorded, mixed, and edited by me, Kyle Wood. Thanks for sharing a part of your day with me. Be sure to follow Fun Facts Daily on your favorite podcast app so you can keep the good stuff coming your way every day. And if you like the show, please do me a favor and leave a kind rating, review, or just tell your friends about it.